Okay, gang, this calculus lesson is on taking the derivative and integrating general exponential functions and log functions. So this is going to be when we have numbers to a variable right here, okay? And this is going to be other logs other than natural log, all right? Let's go ahead and get started. So here we have the derivative of a number to a variable here. So this is a number to a variable equals the function itself times the natural log of this base right here times the chain right there, okay? So don't get that confused with a variable to a number. A variable to a number is something we've already done before. So if I wanted the derivative of this, it's just 3x squared, okay? That we've already done that. This is when we're going to have a number to a variable. So let's go ahead and try one here. So let's find the derivative here. Here I have a number to a variable right there, okay? So it's going to be the function itself, so 2 to the root x times the natural log of 2 right there. This is my base right here, times the chain. Well, just think of this as y equals x to the 1/2 power. So the chain right here is going to be 1/2 x to the negative 1/2. So this is actually 1 over 2x to the positive 1/2, which is 1 over 2 root x. Okay, so here's the chain. Okay, so here's the function times the natural log of the base times the chain. Okay, going to clean it up. Here it is all cleaned up right there. All right, now think of this, you guys. Imagine in your head x to the 5th over x squared. Remember from Algebra 1, that would be x to the 3rd because you'd subtract those exponents. Well, the textbook might take this and subtract the exponents of these base 2's. You know, this is 2 to the root x over 2 to the, there's a little imaginary 1 right there. So they might have it written like this, you guys. 2 to the top exponent minus the bottom exponent. Okay, there's a little imaginary 1 right there. Okay, and then natural log of 2 over square root of x. Alrighty? Alright, so this one here, I'm going to use the product rule. So the derivative of the first one times the second one plus the first one times the derivative of the second one. Remember, it's itself times the natural log of the base times the chain right there. Okay, let's clean it up. I'm going to GCF out a 5x to, I'm sorry, 5 to the 3x power out of both of these guys. So when I GCF out, I'm left with that. I put the 3 out here in front of this x right here, so that's where this is right here. And then look at this, you guys. I floated this 3. Remember, with a logarithm, it goes as the exponent spot, so it's actually 5 cubed, so that's where the 125 came in. All right? And actually, they could have done this. You know, they could have put the x up there, and it would be 125 to the x power, natural log of that. All right, but that's clean enough for me. So it's just, you know, starting to match the answer game in the back of the book. Excuse me. All right, so the derivative of a variable to a variable. When this happens, you guys, you need to natural log both sides. This says natural log both sides. And then you'll bring down the exponent and then implicit differentiate. So let's try this, you guys, okay? So here I have x to the power x squared plus 4. So I'm going to natural log both sides first. All right, when I natural log that, this exponent is going to come floating down in front right there. And then I'm going to implicit differentiate, you guys. So I'm going to do the product rule on this side, and this is going to be 1 over y dy. Okay, so the derivative of natural log is 1 over y dy. Okay, and then when I do product rule, the derivative of this is 2x times the natural log of that. That's what this says right here. And then this one, the derivative of natural log of x is 1 over x. So 1 over x times this gets me this little piece right here. Okay, now I'm gonna combine like terms with a common denominator right here. So I'm gonna multiply this one by x over x. You guys with me? Okay, and so I get that right there, and then I'm going to put this y over here on this side, and so multiply both sides by y, I get to that right there. So there's dy, which is my derivative right there, and then I'm going to substitute this y with my original equation right here, y equals x to the x squared plus 4. So there's the final answer right there. Okay, messy answer. It's not that hard. It's just messy. So whenever you have a variable to a variable, you got to natural log both sides first and slide the exponent out in front and then implicit differentiate. Okay, all right, so the derivatives of general logs, you guys, so other than the natural logs, okay? So if I had, you know, different bases, not base e, which is natural log, okay? So the log base a of u is 1 over u times 1 over the natural log of this base right here, and then times the chain right there. Okay, if I didn't show you this in my prior lesson, but that's how come this one works. You know, this is base e, you guys. Natural log is base e. So following this pattern right here, it'd be 1 over u times 1 over the natural log of this base right here, which is base e, times the chain right there. The natural log of base e is just 1, okay? Because remember, this is base e. My dogs are barking in the background. My wife's going to get home soon, so they're barking. Excuse them. This is base e, so base e, this base to this power over here equals this. So natural log of e just equals 1, you guys. So this is like saying 1 times this right there. So that's why the natural log, the derivative of that was 1 over u du. Okay, but if it's other bases, then you do 1 over u, 1 over this number, times 1 over the natural log of this base right here times the chain. All right, let's try some of these. All right, so find the derivative of each, okay? So it's going to be 1 over the 4x squared, 1 over this piece right here, times 1 over the natural log of this, and then times the chain. The chain of this is 8x. All right, and then clean it up, cancel out things, and you get 2 over x natural log of 7. Okay? All right, let's try another one here. Okay, so here we have y equals log base 4 of a fraction. Okay, we're going to use our algebra 2 skills and expand that natural log. You know, remember this from algebra 2? When you have a fraction, then you can separate it with the numerator minus the denominator with each logarithms. Okay, and then I'm going to use my rule right here for this one and this one right here. Okay, so it's going to be 1 over this times 1 over the natural log of this times the chain. And then same here. 1 over this times 1 over natural log of this base right here times its chain right here. Okay, so that's what that says right there. All right, and then clean it up. And when I clean it up, I yanked out the 1 over the natural log of 4 right here. And then this negative and this negative made it a positive, so I just wrote that one first. It looks a little bit cleaner if you have the negative part second. So anyways, that's the answer. Okay, it's not hard, you guys. Okay, so recall from section A that we just did a few minutes ago, if I have a number to a variable and I'm taking the derivative, it's the function times the natural log of that times du. Okay, well, what do you think integrating is? It's going to be the opposite, you guys. When I integrate, it's going to be the function divided by the natural log divided by the chain. Okay, so here we go. So find the integral of each, okay? Actually, and this is the only problem I'm doing right here. All right, what I'm going to do is do a little u substitution right here. So my u substitution is going to be this exponent right here. So du is going to be 3x squared dx. All right, and then so if I divide both sides by 3, this is my x squared dx right here. So 1/3 is going to be 1/3 5 to the u. Okay, 1/3 the integral of 5 to the u. Okay, so following this, it's going to be 5 to the u over the natural log of 5 times du on the bottom right there. Okay, now let's get this back in here. U is this x to the third. I'm going to substitute that back up in there. And then du, you guys, du, where is that? Du is this 3x squared right there. So I'm going to substitute that back in there and clean it up, and I get that right there. Okay? All right, so I'm going to let you guys give us a shot here. If you're in my calculus class, that would be your homework. Take care.